Right, now here, as I mentioned in the previous video, we are doing a little rearrangement to get some better results, right? So what we do is we add Sn term throughout this inequality, right? Then see what will happen. Now this one you can write it as the without any changes, right? Also the right hand side, but for this term, see, Rn is equal to S minus Sn. Okay, so if we add Sn for Rn, that means we should add Sn for this one as well. So these two things will get cancelled out, leaving you with S, and S means the actual answer of our series, right? So then if we add Sn to both sides, what we will have is an inequality which involves S, right? Which is the actual answer. So it's like we don't even have to deal with those error terms. We can directly obtain some sort of a region for the actual answer directly, right? Say for example, if we consider this question, estimate the sum of this series with, let's take n equals 10, right? Now here you should be familiar with these terms, right? Now here it says estimate, not just find the value. Okay, finding the value means we need to find a certain value, so that, like, if we say that the value is equal to let's say 100, then this series should be equal to 100, right? So it's like, that's what we say, like an exact answer, right? But here it asks to estimate, right? So when it says estimate, you don't have to find a exact answer like this, right? You just need to do some estimation. Especially it involves these inequalities, right? So let's try to figure out that one by using this inequality. Now in the previous video, we used the addition of first 10 terms, okay, and determined the error Rn value, right? And then according to this Rn value, now this Rn represents the difference between S and Sn, where Sn is the sum up to the nth term. And what we did was, we approximated the actual value of the series with this one, with the partial sum, right? Now if we write down the approximation like this, then the error was this one, right? Now let's see what will happen if we use this inequality. Okay, right? So by substituting n equals 10 in all these places, you will get, so you can solve the inequality like this, right? We have substituted n equals 10 here, and we saw that the integral will be equal to this one. K is the lower limit, so accordingly here the lower limit is 11 and here the lower limit is 10, so we can directly substitute those relationships. And also by the calculator you can find the value of S10, right, which is equal to this one. Then by adding all these terms together, you can see that the value of S will be in between these two numbers, right? They are very close numbers, right? See here, 1.2 some 0 something, and this is 1.20, this one, right? Like the difference starts at the third decimal point. Okay, so now we know for sure that the actual answer for the series, which is represented by S, will lie between these two numbers, right? So if we just pick the center point as our S value, so how do we find the center point? We just add these two terms and divide by 2. Then it will be equal to 1.2021. Okay, so if we consider this as our approximation, right, because we know that the actual value should lie between these two numbers, so somewhere here it should definitely have the exact answer. So what we do is we just choose the center point. Okay, that means the maximum error that this number can have is the half of this distance, because we know that the actual value should lie somewhere in between, right? So let's say if it is here, the error will be the distance between the estimated value, which is this one and this one, right? So the maximum distance that this can go is up to this point or up to this point, so which in turn says that the maximum error that you can have is the is this length, the half of this total length, right? And that length is equal to 0. Like if you subtract this number from this one, you can see that it is equal to 0.0005. Okay, now see, here you have used, like here we used this inequality. Okay, and by using this inequality, only with 10 terms we were able to find or to approximate S, which is in this case 1.021, for an accuracy of 0.0005. Okay, but if we now see here, it says like, now here we are not directly assuming that the series will be approximately equal to the partial sum. Okay, we are not using this sort of a relationship in here. Okay, we just have the partial sum in a corner, right, and we directly evaluate or approximate the final answer. Okay, but in the previous video what we did was we take a number n, and let's take 10, and then we derived a certain formula that gives the error, right? So from this one, what it says is we are approximating the final answer with partial sums, right? Here we approximated it through partial sums, but here we are not doing such a thing, right? So now it will be clear to you in a little moment. Now from this calculation, it said that if we used 10 terms, then the approximation or the error will be at most 0.0005. Okay, but we saw that in the previous problem, actually it was the second part of the previous problem, when we use this relationship, okay, in order to get this accuracy, we needed 32 terms, right? So that means if we are using this one, we will need 32 terms. That means if we add 32, if we add the first 32 terms, then the value of that one and the actual answer, the difference will be less than or equal to 0.0005. But here what we did was a different thing. Okay, that has nothing to do with approximating the series with partial sums. Okay, here we used a different technique. It's like we have a inequality and we evaluated the inequality terms and then directly obtained a relationship for the actual answer, right? And by considering the midterm, we saw that since the actual answer should lie between these two numbers, if we approximated, now see here, this is the point that we are doing the approximation, okay? But here, this is how we are going to approximate. It's through the partial sums, but here we first figure out the interval and then consider the midpoint as the approximation. Okay, right. So with this approximation, we saw that the maximum that it can go is less than or equal to 0.0005. That means the error should be this one. So basically, by using 10 terms, by just using 10 terms, we were able to obtain the same accuracy as we used 32 terms in the previous case, right? So that's why we consider this inequality as a better way of determining the value of series, right? Okay, so you must clearly understand the difference between this one and the previous steps, right? I mean the previous inequality. Here we do a direct estimation, and in the previous case we approximate the series through partial sums. And in the next couple of videos I will move to section 11.4, which discuss some more theorems to determine the convergence.